More?
Yes.
Hold on, Martha. Alright, now we're going to move all 3 cups around so that my volunteers don't know who's going to get the cup with the water. You can't look, you got to look that way. Hold that one carefully. Hold that one carefully. And hold that one carefully. Alright, let's see if we have any water left in cup number 1.
Uh-oh.
Thought there was water. You didn't know you could splash them, did you? Here we go. Let's try number 2. Now, cup number 3. So, everybody count to 3.
I didn't drink it.
You didn't drink it? Did you? Did you? Who drank my water? Somebody here drank my water. You drank it! You drank it! Now, this young lady was a little worried because it's heavy. That means our water is still in here. Well, it can't be ice because we had no way to freeze it. It can't be a gas because it would have blown away. So we still have water in here, but it's not a liquid, or my hand would be wet and so would her head. So let's see what we turn it into. We turn our liquid into plastic jello. Now, this is how we did it. In the 3rd cup, one on this young lady's head, I had put a special powder called polyacrylate powder. It absorbs 200 times its weight in water. So I could have used a lot more water and still had something much bigger than this. But here's the really weird thing. It's where you can find a powder like this one. Pampers Diapers! Yep. Powder's in the diaper, baby adds a liquid, then you get a solid. Now, don't go home and tear open a Pampers diaper. Because what we use is 10 times stronger. If they used what we use, every time a baby went potty in the Pampers, it would go, uh-oh. This doesn't work, I can't move. So, we use something much stronger. Let's hear it for my volunteers! Good job. Thank you, Jesse. You're welcome. Well, I thought about doing that one. But then I thought, no, there might be some other scientist who's going to try that one. Because that's a very popular one of making something seem to disappear, and actually it just changes its form. So I thought, and I thought, and I thought, and of course again, I fell asleep.
Oh no.
And in my dream this time, I was dreaming about a world where everything went boo. And I thought, does that mean I'm underwater? No, it seems different than water. It seems thicker than water. It seems like slime. So I thought, of course, everybody loves slime. So I thought, my beaker, and I let it sit. For about 3 days, that liquid would become as solid as this bottle. But that's not what I want. I want to make something nice and thick and gooey. So, here we go. You stir that and sodium borate together. And so but then I thought, now wait a minute. The other scientists have probably made slime too. But maybe they never thought to add a gas to it. So I was thinking I'd add this gas. Now everybody go, you just blew out the same gas that's in here. It's called carbon dioxide, or CO2. Everybody go C. CO2. So, if I took this, and I took my slime, and I poured my slime in here, I could shoot slime with them. Even if I didn't win, it would be fun. So I thought I'd give it a try. Boom. Here we go. Now, let's see. Oh, wait. There was something I... Oh, that's what it is. If you get liquid plastic in your hair, it's kind of hard to get out. So let's see, who's got the shortest hair? That might be short enough. That could be short enough. Oh, maybe that one. You know, on second thought, maybe I should just try longer hair. Let's see, we got longer hair here. That's a little bit longer. That's nice and long there. That's nice and long there. There we go. Did you really think I would shoot slime at you? No way! Your hair would end up like mine! dioxide. Now this guy was warm a second ago. Now he's as cold as an ice cube. When carbon dioxide gas comes out from under pressure, it gets cold and it grabs water molecules out of the air and makes fog. So when you guys get up on a cold morning and you can see your breath, you're becoming fog machines. Well, I thought that might be pretty good, but then I thought, you know, on second thought, I really would like to win this thing. And that means if I went ahead and I shot slime all over the judges, they'd probably go, I don't think you're going to win. You slimed me. So I thought, okay, that doesn't work, but I like the idea of using CO2. So I thought about it again, and again, and again, and again. And of course, whenever I think hard, I... You guys are a great alarm clock. Sheesh! Well, this time I thought, wait a minute. What else can you do with CO2? I started thinking about this guy and how cold it got. Well, if it got cold, what would happen if I made CO2 very, very cold? Well, if I put it in a special freezer and I drop the temperature to 109 below zero, I'd end up with dry ice. Now, we call this dry ice because there's no water in it at all. This is frozen CO2 gas. Now, it's at 109 degrees below zero right now. That's why I don't touch it with my bare hands. If you do, and you hold on too long, then the water in your skin freezes to the ice. Then when you take your hand away, some of your skin stays there. And your hand says, I don't like you anymore, that was really stupid, don't do it again. I'm going to hurt a lot now. So I said, okay, don't worry, I won't hold you, but I'll hold you with my glove. Now let's see just how cold dry ice can be. We're going to try some different types of metal and see if we can make the molecules in our metal move closer together, just by coming in contact with something this cold. So the first thing we're going to try is some quarters. Now, these are supposed to last 100 years. That means the molecules in here are packed very, very tight. But if I put them on the dry ice, they're going to move closer together because they're going to get very cold. And when they do, they're going to talk to us. So let's hear what they have to say. That's the sound of molecules saying, "We're freezing!" Yes, I think you are. You look pretty cold. I don't know. Don't put me on there. Don't put me on there. Sorry. But this guy will shiver.
Oh, look at that.
So what's happening now is as my dry ice sublimates, that's what we call it, as it turns back into a gas, it makes the quarter go back and forth. It's getting hit back and forth by the gas itself. And the part of it that's stuck in the ice, that part is saying, guess what? I'm freezing. So we know we can freeze it with that guy. But let's see what would happen if we tried the spoon I use for my cereal in the morning. I can eat a whole bowl of cereal in only 2 spoonfuls. But I need some volunteers to help me with this one. Sir, come on up. Come on up. And sir, come on up. Now, this is what I'm going to have my volunteers do. First, let's find out who you are. Ma'am, who are you? Very good. Sir. And sir. Very good. This is what my 3 volunteers are going to do. Each one is going to hold on to the spoon and then put it on the ice. You want to hold it there, don't move it, and let's see if it makes a sound. Yeah, that's the sound of the metal going, what are you doing to us? You're freezing us! Let's warm it up again. Excellent. And again. So that is thicker metal than my quarter. That's why we get that sound. Let's hear it for these 3 volunteers. And there. But now let's try the spoon a different way. So I need 3 more volunteers. And alright, now, this is what these 3 people are going to do. They're going to hold it by the spoon part and put the handle on the ice. Let's see if we get a different sound. we get a higher sound. The thinner the metal, the higher the sound. Now my spoon says, oh great, I'm getting frozen everywhere. See if you get any cereal tomorrow. And now let's see what happens if we were to put this guy on it.
But let's put it on your tablet and give me, okay?
An even higher sound. So it depends on the metal, but all it's doing is making the molecules move closer together. Metal molecules are what we call three-dimensional. So they have more surface area to touch and to rub when they shrink. And that's what gives us our nice loud noise. So let's hear it for these volunteers. Well, now we're going to see if we can use this to make a fog machine. Because I started thinking about the fact that we are fog machines when we breathe out CO2 on a cold morning. Maybe I could make one. So I took this guy and this guy. I said, let's put some dry ice inside of some hot water. Now when we do that, it makes fog. What's happening now is the CO2, the gas, our frozen dry ice, is sublimating. As it does, it comes up through the water, it grabs the water, and it makes a nice cool fog. Oh, I know. Let's see. Now the grown-ups should get to have some fun too, so we're going to fog some grown-ups. Right in the glasses there. There we go. Here we go. Fogging them up. Fogging them up. Here we go. Let's come on over here. A little bit of fog. A little bit of fog. A little bit of fog there. A little bit of fog over here. A little bit of fog over there. Wait. She's thinking till her heart brain's on fire. Now, we're going to get the other adults, but with a different experiment. Because what we want to do now is see what happens if I don't let the fog out this way. Where's it going to go? What do you think? Up?
It's going to build up and then make it, the top usually pops off.
Alright, let's see if that works. Let's shoot it over this way, hands up.
Me too.
So that is gas under pressure, just like with my slime shooter.
I didn't know we had a flamethrower here.
Oh.
Yeah.
Let's try straight up and see what it does. Whoa!
I know, wow.
So, we saw that my cork can shoot through the air using fog. But let's see what happens if we add dry ice to this guy. This one seems a little different.
Oh, that's so.
This makes a bubbling volcano. So this one we're going to bring around for the grown-ups on this side. Have some bubbles.
How do you have the bubbles? I don't want to eat bubbles. I love playing with
Let's try some. Just dish soap. Got fog bubbles. So I thought, well, that's pretty cool, but maybe they've seen fog bubbles before. Then I thought, well, wait a minute. Maybe I could try to make a really big fog bubble. So I said, let's put some dry ice into some hot water. Then I'm going to take a bandana that's got a bunch of different types of soap on it and see if I can make a very big bubble. Gotta get it just right so we have just enough fog, just enough bubble.
It looks like
Excuse me.
And that is a big bubble.
Nice.
Leave it there. Leave it there.
We're going to see how far it goes. It's getting bigger and bigger. Now, you might be able to see the different colors on the top. That is the rainbow effect. When you've got anything that's got water in it and light hits it, you're going to see the different colors of the rainbow. Let's see how big you get. So as this sublimates, then it makes fog. The fog starts to fill up the bubble starts to get bigger, and then the bubble goes, oh my goodness, sooner or later I'm going to have to pop. Yes, you are. Well, we want to see if it goes this way, that way, or this way. Once it gets heavy enough, it's going to start to slide one side or the other, and then it's going to pop. Who thinks it's going to go forward? Who thinks it'll go backwards? Who thinks it'll go this way? Who thinks it'll go that way? Let's see. It says I'm getting big all the way around. Which way are you going to go? Oh my goodness. It's getting bigger. It's getting bigger. It's getting bigger. It's getting bigger. The Bubble Lake, California! What are you doing? How big are you going to get? You're huge! Oh, don't get near it. Let's see if it'll go. And it goes this way. Let's add just a little more dry ice and see if we can get an even bigger bubble. Here we go. Now, one of the things that's happening is the water is getting very, very cold because of the dry ice. The water in this guy was warm when I started. Now it's got some regular ice beginning to form. So it's cold enough that it will start to freeze water in no time at all. So our water's getting colder, but our fog is still going. So let's see how big you get. Now, if I go like this and move the air, we can get a jello bubble. What are you doing? What are you doing? What are you doing? I'm gonna pop, I'm gonna pop, I'm gonna pop. You're getting huge! How big you gonna get? This is pretty big.
Oh no.
Here it goes, here it goes, here it goes, here it goes, and it likes to go that way. Well then, I said, you know, that's pretty good. But a lot of scientists use dry ice. So maybe I should think of something else. So again, I thought, this time I thought really, really hard, and sure enough, is there a snooze button on this alarm? Yes, there is. Well, this time I dreamt about a bigger volcano. I thought, wait a minute, this is pretty cool, but what if I could make a bigger volcano? And what if I could make this volcano out of some different chemicals instead of with dry ice? So I decided I would. So the chemicals that I chose were these. This is hydrogen peroxide, 30%. Now you guys may have hydrogen peroxide at home, but that's only 3% strong. We pour it on a cut and it kills germs. This is 10 times stronger. You would never ever pour this on a cut. If you did, it would turn your skin as white as my lab coat, and it would feel like a bunch of needles poking it. Once you wash it off, then you're okay. So this can be a pretty nasty chemical, so we're careful with that one. But then I also need to add some dish soap. If I add dish soap, then I can get foam. And the foam will look like lava. Well, if I've got something I want to have look like lava, I should add food coloring. But then I have to add this guy, potassium iodide crystals. Now these guys are very strong. If I add these to my volcano, to this chemical, it's going to make the chemical very upset. And the molecules are going to start to move faster and faster and faster and faster. And when they do, they're going to start to make heat. And the heat is going to make hot foam. And the hot foam is going to need somewhere to go. And it's going to say, look out, here I come. And that will be my volcano. So, let's see if I can do that. Now, I'm going to put in this chemical. Because that's the dangerous one. But now I need a volunteer to come on up and help me put in the soap. Now, come on up. Wait, did you already come up? Okay, let me get somebody who hasn't been up. You haven't been up yet? Come on up. Oh, hold on. Now, what you're going to do is you're going to put this here and then give it 2 strong squeezes. So 1 and 2. Perfect. Let's hear it for my volunteer. But now we need to add some food coloring. So I need another volunteer. Come on over here. I'm going to hold it. Come on over here. I'm going to hold this right here, and you and I will squeeze it together, okay? So bring your hand up here, and we'll squeeze. There we go. We got it. Good job. Let's hear it for my other volunteer. So, now we're ready. We're going to add our potassium iodide crystals. And when we do, then we're going to start to see our volcano. So, let me get both of my gloves on. And everybody count to 3. 1, 2, 3. In go my crystals. Now we're starting to get a reaction. Here it goes, here it goes, here it goes, here it goes. Wow! We've got a volcano! Don't sit up! Give me back my bottle! It's eating my bottle! It's alive! It's alive!
Don't detest it!
Don't sit up! Stop, Fifi! I command you to stop! I ask you to stop. I beg you to stop. Now this may look like a Slurpee, but you would not want to eat it. One thing, it's very, very hot. But it still has that chemical in it, so we still have to be careful. Now this is what we call an exothermic reaction. Exo means out, thermic means heat. So everybody go, exo! Thermic! Reaction! When you get an exothermic reaction, you release a lot of heat. So we went from something very, very cold to something very, very hot. Well, I thought, okay, they can't beat the volcano. But then I thought, wait a minute, maybe they can. So I started thinking about all the famous scientists from the past. Things they had done, different experiments they had tried, new theories they came up with. And I thought about them, and I thought about them, and... oh my. And in my dream, I dreamt that I saw Isaac Newton. Now, Isaac Newton was the man who figured out gravity. Story goes, he was sitting underneath the tree when a piece of fruit fell and hit him on the head. He looked up and went, "What's up with that?"
No, I didn't.
He wanted to know why gravity made things go down. Well, he figured out the Earth is big enough, it spins fast enough, that makes enough gravity, so that it pulls everything towards the center of the Earth. Well, he also came with something called the 3 laws of motion. Now, the first law of motion says that a body at rest will remain at rest until acted on by an outside force. This is what that means. This cup won't move until something makes it move, because it can't move by itself. So, it is a body at rest. I am an outside force. I'm going to make it move. you move. So that's our first law. Then I thought, wait a minute. The second law is that once something starts moving, it has a tendency to keep moving unless something stops it. Again, outside force. So if this guy drops, he'll only stop because he hit something. If this guy is thrown, he'll only stop because gravity pulls him down, friction slows him down, and then he has to stop. But our third law is the one I like the best. It says for every action, there's an equal and opposite reaction. What that means is if I hit this guy just a little bit, he falls right over. But if I use a greater force, he's going to go a farther distance, like that. So I thought, okay, that's pretty good, but just using a cup, that probably wouldn't impress them. So I thought, let's try a jet car. Now, for this, you guys might want to move over that way, because we're going to get some spray coming out this way.
I have one question. What is it?
This, we use a fire extinguisher. So what we're going to do is use compressed CO2. When the CO2 comes out, it's going to come out from the back. So let's take out our safety key, like that. Now, if the gas comes out this way, then it pushes the car that way. Our equal and opposite reaction. So we're going to see if we can get this guy to move and see if that will work. Now, let me look and see. I think I've got a pair of safety goggles. Yes, I do. So I need a volunteer who is just the right size. Has to be just the right size for this one. Sir, right there in the white t-shirt. Come on up. Now, wait, have you already been up? You already up? Let's see if we have somebody else good about that size. That should work. Come on up. Now, I'm going to have you put on the safety goggles. What's on your head? Now you're going to sit down here. Above your nose, though. There we go. Now, go ahead and sit down here. Got it? One foot up here. Now when I say go, this is what I'm going to do. I'm going to move the table back a little bit so we have a little more room for you. I'm going to give you a bit of a push to get you going. Then I'm going to say go. And when I say go, you're going to push down on this. Then I'll get in front of you and I'll say stop. When I say stop, just let go of that and I'll stop the car. Okay? Alright, here we go. Let's move you back a little bit so we can give you a bit of a push from here. And push. Now, let me give you a sticker. Good job, man. But let's see if we have a young man who would like to try the jet car too. Sir, right there. Good size. Come on up.
All right, Luke. Yeah.
Go ahead and sit down on here. Oh, careful.
It's okay, Luke. You're good, buddy. I wonder why you were the cat.
Now, when I say go, you'll push down.
Austin, your brother.
You let go, and I'll stop the car. Moving. And go. Push down.
Yeah, buddy! All right, girls, sit down.
Here we go.
Yes,
So, I thought that might be the best experiment to use. But let's find out what you guys think. Who thinks I should try the one with the stuff from Pampers diapers? Who thinks I should try shooting the judges with slime? Who thinks I should try using the dry ice? Who thinks I should do the volcano? And who thinks I should do the jet car? I think the volcano wins. So that will be the one that I will take with me up to Montreal to see if they've seen that experiment and to see if I can win. Now, all of this happened because I had dreams. And in my dreams, hold on, I dreamt big. I always dream of things that are big. Not just big things, but big ideas. Because remember, Albert Einstein, the most famous scientist of our time, he said imagination is as important as knowledge. What that means is I can teach you how to do all of this. But if you don't use your imagination, you never come up with anything new. So imagination is very important. And you guys have great imaginations. So that is how I dream big, and that is how I use my imagination. You guys have been great. Give yourselves a hand. Now, do we have any questions about our experiments? Sir?
When you win something, are you gonna come back and tell us?
Hopefully, yeah.
Oh, yeah.
Yeah.
For the lava, the little crystals that you put in there, how come they make it hot?
Well, an exothermic reaction happens because when the chemical gets excited, the molecules begin to go like this, and that creates friction. The friction creates the heat, and then the heat makes the hot foam come. So it's just that what they do is make my chemical let its energy go. Because it has all this energy, it's going to release it. All these guys do is help that happen. Any other questions? Sir? Well, because the gas is lighter than the water. So it's going to rise up, the water will stay there, and then the gas bubbles will rise up because they don't weigh as much. And so they're going to go up. It's just like if you're underwater and you let some bubbles out if you hold your breath, those bubbles always go up. Questions, sir?
You want that one?
Any other questions?
We do these at home, and if so, where do you want it?
Yeah, most of these you can't do at home. You can do a volcano at home using baking soda and vinegar. A little bit of red food coloring, and you're going to have something that looks like a volcano. These you can do if you could buy the dry ice. You can get that at a store if you're over 18. The slime is kind of hard because we make our own ingredients for this. So I don't know if somebody else sells those. And the slush powder you can buy online. Now let me show you quickly what it looks like when it works. Let me pour a little in a clear cup so you guys can see what happens to it. So that is our polyacrylate powder. Now let's add water to it, and you can see how quickly it turns into the gel. 1, 2, 3, 4, 5. There we go. So that is very, very fast acting gel. You only have to put it in, count to 5, and you've got yourself something that expands. Any other questions? The gel? Yeah, you can touch it, but you don't want to get it near your eyes. It's much stronger than what they have in the diapers, and because of that, they advise that they don't want people to get it near their eyes, because it can really irritate your eyes a little bit. Any others? Question? No? Well, you don't mix the dry ice with baking oil because you won't get fogged that way. The oil is going to trap the gas, and then it's not going to rise as well. So it's much better if you use water, warm water, than a type of oil. Now, I've got some cards for everybody, and these show you an experiment you can do at home. They also give you a discount coupon on the other side for Madscience. And this way, everybody leaves with something.
Do you want to go get an experiment card?
You're welcome. You're welcome. You're welcome.
Nice job, my group up there. Thank you.
And this one back.
I won't rush. I cannot change.
You got one?
Good job, thank you. When are you going up to Montana?
Well, we don't know yet. We're waiting to find out.
Is the group you're going?
No, just what you mean.
Just you from San Diego?
Why don't we get like, make 5 or 6
All right, guys. That's our science show for today. Thank you so much.
Oh, thank you.
Thanks a lot for coming, you guys. I want to remind you a couple things. Check out our calendars in there up at the desk because it tells you all the fun stuff that's happening over the summer. Does anybody know what's happening next Thursday? It's the Raggle Taggle Band. You guys ever seen Raggle Taggle? They're a pirate band. They're really good. They're going to perform right here next Thursday. At what time? Anybody know?